So I'm about to introduce our next speaker, Barry, Prof. Barry Ewin from North University College. Barry is a local fellow from Rhodes University, but he started off as a systems and network administrator at the dawn of the millennium and tripped and fell into the security field. Finding nothing on the market that met operational need. He led development and deployment of an open source derived firewalling system in the early 2000s for global telecoms operator. He returned to academia and has spent 21 years working in academia on research in large information security field, often returning to his first love, packets and network traffic analysis. He has a significant experience and passion for training the next generation security professionals within academia and cross-section public and private sector industry. His current areas of interest include network traffic analysis, data visualization, web-based malware, botnet identification and anti-phishing. Prior to relocating to Norway from South Africa in 2019, he developed and headed a very successful information security postgraduate program at Rhodes. He has a love for military history, especially as it relates to codes, ciphers, espionage, and somewhat domain racanologist. It's long, but I've just tried to cut Barry's profile a bit short. Welcome on stage, Barry. Thank you.
Thank you very much. All right, I can actually see the slides without glasses. That's one of the downsides of getting old. All right, welcome. Lovely to be back in South Africa. Today I'm going to be talking about something slightly different. It's probably got a bit more of a technical bent to it. I've tried to take a lot of the technical stuff out, though, recognizing that we're dealing with not just a cybersecurity audience or computer science or networking audience, but a far more diverse. So what I'm hoping to really do is say, what is the big picture around this? And as the title suggests, I want to talk today about DNS. DNS is one of the key things, and really to go back to this haiku that you see popping up all over the place. Anyone who's worked in network operations, you've debugged problems, and you know, you start off, it definitely wasn't DNS. There's absolutely no way that the problem could be a DNS-related outage. Oh, it was DNS. DNS is so completely integrated into our modern systems. We use it for the name resolution, going from google.com to an IP address, but it also underlies trust. And the services that we've just been hearing about, things like EduRoam, the whole X509 certificate infrastructure, is all very much anchored around the DNS system actually working. So effectively, things break badly when DNS breaks. And this is a problem I've sort of been fiddling with for probably 10 years now. But in recent years, there was sort of some good sort of incidents that happened that made me start thinking about. We spend a lot of time talking about critical infrastructure. And critical infrastructure, it can be different things to different people, and we'll come back right at the end of the talk and we'll revisit this whole idea of critical infrastructure. But effectively, what I want to sort of postulate to you today is that DNS is critical infrastructure, and it's one of the things that is at a national level we should be taking seriously. Every single country should be taking it seriously, because if DNS infrastructure fails for a variety of different reasons, we'll look at some case studies and impact as to how this can happen, bad things effectively come from it. If DNS fails, or if DNS is subverted, the entire sort of, well, not the entire, very large parts of the trust hierarchy that we have on the modern internet today effectively cease to exist. They collapse. So pretty much everything that we use today relies on DNS at some point, whether it be, as I said, the name resolution, certificates, service provisioning, email. You don't have DNS, email doesn't work. You don't have DNS, a whole lot of the anti-spam features, things like DMARC, SPF, etc., also don't work. So I'm going to start off with a disclaimer here. Probably the most important thing at the end here is that views are my own. I'm making some broad strokes, some assumptions based on partial data that is incomplete and not necessarily wholly accurate, and I'll get to why that is the case. A lot of what I'm talking about today is really easy for the people that own the data to be able to do and do very well. As an outsider trying to effectively third-party scrape and get access to data, you end up with holes. But when you start doing it at scale, the holes become less and less significant. Anyway, that's the disclaimer around this. Most of the data I'm going to be presenting today has been collected over about 14 months, spanning 3 years. And I've tried to summarize what the general trends are. I have got some absolute data in a couple of slides' time. That was a snapshot as of January this year. We'll talk more about those when we get there. So the question I really started with is, why do we need to sort of really look at DNS? Why do we really care about it? What are we doing about the whole thing? And then we started saying, well, what is the core of DNS? Well, the core of DNS is how DNS actually works, the name resolution system. Going from you type a name in, you go to your local resolver, it goes to an upstream resolver, effectively goes all the way back to the root servers, who will then say, hey, I'm looking for a Norwegian domain. Go and talk to these machines out on the internet that handle .no, for example. And exactly the same happens with all the country-level, top-level domains, or the CC domains. And that is really where I've focused, is not looking at the sort of the .com, .net, .biz, .tv, and all those the absolute top levels, but rather the country level, because that is something where we can often have a lot more influence at a national level. Should DNS be regarded as a national resource? In some organizations, but you look at Trinidad and Tobago, they've monetized their .to domain. It's largely not used for within the country, but it's monetized. And so it is being turned into, I use the term very loosely, a natural resource that can actually go about being exploited. So looking at the country domains, the next question was, for a given country domain, what proportion of the name servers that are serving the domains in that are actually located outside the geographic confines of that country? Leading on from that, what is the risk to DNS as a critical infrastructure if somebody manipulates, takes down, destroys, disrupts? What is that going to actually be? And while doing all this investigation, a lot of it was about just crunching data, lots and lots of data. I learned some very valuable lessons about how not to do data processing, how not to do data collection. If I remember correctly, a single scrape run of data was around about 38 to 40 gigs, and I was doing this every 72 hours. It got really big, really fast, and as I've run through the process, I've gone down from an initial 18 hours sort of run time. I can do most of the queries now in 12 minutes in terms of collecting fresh data, just through going through sort of a good network architecture, using different sets of tools, etc. That, however, is not what we're going to talk about today. What I did, though, is while I was doing a lot of the query, it made sense to try and stack up some other queries. So one of the things I looked at was DNS and DNSSEC. DNSSEC, for those of you that aren't aware, it's a set of standards that have been around for quite some time now that allow you to go about cryptographically signing your domains. In other words, adding another level of trust. The vast majority of clients out there don't care, but people who do care can actually cryptographically validate that the lookup that they've done has not been impacted along the way. The other element that I looked at was the CAA records, and we'll come back to those. So all of this had been sort of mulling around in my head. And then we had February 2022. I'm not going to dig into the incident as much sort of as specifically, but it really made me think. We had kinetic warfare taking place. Surely what was happening in cyberspace, and there was certainly a huge amount of impact in cyberspace from both sides. We saw evidence of denial of service attacks, etc. But one of the things that we saw was, in the case of Russia, a massive national effort to remove DNS servers for .ru domains that were sitting outside of Russia. And we'll look at some of the stats where it sits now. There's a marked improvement from where it was before. So that was the one big incident. Revisiting this talk and sort of thinking about it, we can look at it's not just sort of the bad actors out there that can disrupt DNS, but as most of you have probably experienced, Africa's had two specifically significant cable breaks this year in March and May, looking at the East Coast outage, and then there was a West Coast outage. And that in itself can have a very negative impact. We'll have a look at some of the data I've got. I just did South Africa as a case study. What does that mean when the DNS for a large portion of your country is on the other end of a broken submarine cable? Yes, we are lucky. There's a lot of redundancy today. So many of you will probably be able to remember back to the days when we only had the SAT3 cable running up the west coast. When things went out there, it was a really bad situation for networking. We had some terrestrial satellite links and stuff, but it was slow. So it's about also recognizing what can happen from, in these cases, unintentional outages. Does this impact? What happens if core government services? What about commercial services? If your DNS lookup is taking that much longer from a commercial entity, your website's slow, your competitor's website is fast. Most people are not going to be prepared to sit and wait. They say, the website's slow, let's go and buy from somebody else. So it can have a distinct impact on commercial aspects as well. So gathering data, and this is about as technical as it's going to get, was a really interesting challenge. Back in the warm, fuzzy days of the early internet, if you wanted the domains or details that were sitting on a name server, you would just say, hey, name server, do an AX for me and tell me all the stuff you've got. We've turned that off. It's been there, believe it or not, there are still quite a number of name servers out there where you can do it, but the majority of sort of authoritative domain servers don't allow this anymore for a whole variety of reasons, data leakage, but also the ability to leverage this for denial of service. So the question was, I couldn't go about just getting domains, so I had to go through various other third parties. It was a lot harder than I thought, and this is where it comes back to, we have incomplete data. I largely pulled this from other projects that had done DNS surveys over the years for a variety of different domains. I pulled it from top listings of websites for various countries. As I said, it's not perfect, but the volumes of data I was able to get, I'm comfortable with the kind of things I'm saying. All of this would be really easy if the various domain authorities were interested, happy to share, etc. You have got some countries. Spain is one. The registrar for the .es domain says, hey, you want access? Fill in a form here and you can download it immediately, as many times as you want. Estonia also has a very open policy for its domain registrations. Other countries, very much not the case. So we got all this data, and then we had to start saying, well, we've got a list of host names because we've collected web traffic and sort of statistics like that, but a host name is not a domain, and you've got to sort of convert backwards. Different CCTLDs have very different approaches. South Africa, for example, has a very structured approach. You've got org.za, co.za, act.za, net.za, etc. Others, like Norway, we don't have a second-level domain. It's just whatever you want to .no. And that the same is prevalent in Sweden and several other places. So there's sort of very different approaches to how domains are structured, and one needs to take that into account when you're building the tools to do the scraping and collecting. What was really interesting is, on average, anytime you ran a query, about 8% of the domains, regardless of what country you were querying, they don't exist. They've actually fallen out, they've been deregistered, etc. So this also indicates that the DNS ecosystem is not actually perfect, but it is what it is. It's more of an anecdotal sort of finding along the way. Timeouts. It's one of the major problems when you're running a DNS service. How do you ensure that the domain remains resolvable? And this comes back to what happens if connectivity is lost. You want to try and have diversity. So you don't necessarily, if you've got an important domain, you don't want it running on two machines sitting right next to each other on the same switch in the same data center in the same subnet. You would try and have some geographic distribution, etc. So I was pleasantly surprised that generally less than 1% of the total data that I looked at was unable to be queried at all. Sometimes it took 2 or 3 runs, or attempts sort of a couple of hours apart to be able to get it, but they're there. And the numbers I'm representing, they're sort of the broad picture. This is sort of representative of what I saw over a number of the different runs. I've spoken about the various domains, etc. One of the things that I did use that was quite useful as a sort of global benchmark across sort of the world for general DNS reachability was the so-called Majestic Million list. It's supposedly a list of the top 1 million e-commerce sites or access sites around the world. There's arguments for it, against it. At the end of the day, it's a list. Use it and be careful how you interpret the data. So I used that as input as well. Some of the issues that I did find with the processing, obviously timeouts I've spoken about. A surprising number of domains returned authoritative DNS servers that are RFC 1918. Or for the more up-to-date, the RFC 3330, I think it's 57, something along like that. But they're generally known as RFC 1918. These are private use addresses that are not intended ever for public internet usage. So it was really interesting to see domains that actually had published these and say, hey, you want an authoritative response about my domain, talk to this private server, which is, of course, never going to actually be reachable. So what was we found treasure at the end of the day. To the best of my knowledge, nobody had done this kind of work at scale. I've presented some of this work at sort of previous conferences. It's not at the point where I'm comfortable to call it a suitable academic research in terms of, again, the quality issues around the data. But imperfect is still better than nothing. And I think that is a really important thing. One can sit and talk about it forever and say, well, we can't do anything because the data is not perfect. Imperfect data is still better than no data at all. So generally around this, I've used around about 10 million domains across, I think, 6 countries for this initial case study, 32 or 320,000 different name servers. And that's when you start saying 10 million domains, 320,000 name servers, you start finding some really, really interesting things. There are some name servers that are far more important than others in the world. And we have seen this to some extent. If you cast your mind back to sort of late 2016, the Mirai botnet came out and major denial of service attack against DynDNS caused significant outages across the world because DynDNS is a really popular commercial hosting provider for DNS. Their servers were knocked out at all their access nodes around the world by this massive IoT-driven denial of service attack. And that obviously had a knock-on effect all over the world, for e-commerce, government sites, etc. So then we need to talk about lies, statistics, etc. Mark Twain, this is often attributed to him to say there are 3 kinds of lies: lies, damn lies, and statistics. But that in itself might actually be a lie, because it's also attributed to Benjamin Disraeli, who said lies, damn lies, and statistics. So take it as you wish. Statistics, one can always massage the statistics to fit whatever narrative you'd like to try and do. Being very wary of that, I'm trying to just present the numbers, and I'll paint some broad pictures, and you can decide how you're going to go about interpreting it. So the data quality is a major concern. And how do we do this with poor quality data? How do we really sort of push forward to make policy, talk to network operators, talk to national DNS registrars, etc., when we can't back it up saying we've got quality data? And as I said earlier, incomplete data is not necessarily bad data. And if you're talking to the people who control these things, they have access to perfect data. So it's more of a call to arms and a case of let's start talking about it. Let's start thinking about what is actually going on, what we need to do. The people that need to be able to make these decisions can enable access to perfect data. But still, imperfect data is better than no data at all. So what's left in the talk now is really talking about, there's 2 distinct areas that I want to talk about. The first of these is the analysis, and I'm going to go skip over this fairly quickly. If anybody wants to talk afterwards around some of the nitty-gritty of the analysis tools, the techniques, data volumes, how we did compression, storage, all the rest of it, I'm quite happy to do that. But I don't think that's going to excite most people in a sort of a generalist audience. The 2 areas I want to focus on here, though, are DNSSEC and CAA. DNSSEC, we've spoken about, in CAA we'll come to in a couple of slides' time. As I said, I don't want to spend a huge amount of time around this. Needless to say, I went to school for the first probably year that I was doing this. Lots of data, lots of irrelevant data, trying to get deduplication, trying to find efficient ways to store it. So that in itself was a really interesting learning point for me. But as I've got there, just the laser pointer work, I'm down to about 12 minutes per million queries. And I think I can probably halve that still with a little bit of tweaking and playing with some of the memory caching and overriding various things that necessarily shouldn't be overridden on a public-facing DNS server. So one of the key tools I have used around this that has worked very well is the ZDNS tool. It was certainly a lot faster than my initial approach of sort of for X in domain, do a query, look it up. And that was taking about 3 days per 600,000 queries. It was really slow. So I have managed to get things a whole lot faster. I've learned, I thought I knew DNS. I've been sort of operating DNS servers for nearly 20 years. And then I started doing this, and now I really feel I know DNS in terms of DNS operations, integration, some of the tweaks you can do at the protocol level. So one of the processing challenges around this were to, how do we collect all the raw inputs and turn it into something that could actually be useful? How do we collect this information, expired domains? How do we deal with upstream routing issues, connectivity issues? And part of that was building a distributed collection framework that was globally distributed, that also made use of the open public resolvers. That in itself was a significant performance increase, because in many cases, these resolvers, the likes of Google, Quad1, etc., were able to answer from their geographically close caches. And that was a significant bump in performance. Lots of configuration errors that needed to be worked around. Filters put in place. For example, you collect, these are the name servers you need to talk to, be able to look them up. Oh, they're private addresses. Well, don't even waste time trying to probe those. Skip over, make a note, and move on. And then we needed to take all the data, post-process, etc. Going through lots and lots of processing, retries. You do a batch, you catch all the domains that didn't time out. You try them again, you try them again. After how many retries do you stop trying them? How do you clean up your list for the next pass? Going through. From an actual tooling perspective, again, you're welcome to come chat to me afterwards, some of the details, but it was remarkably simple. Mostly everything was written in Bash. Maybe it's a bad thing, but Bash was probably the first language I felt really comfortable with. I still write most things in Bash. Only when Bash is too slow will I deign to move to something like Python or C. But Bash for me is sort of a rapid application development, and it really runs everywhere, unlike Java. But I've used some more modern tooling, things like JQ, etc. And at the end of the day, one comes back to spreadsheets. The spreadsheets are still a really useful tool, taking stuff from relational databases, putting them in your spreadsheets, particularly for doing sanity checking along the way. So iteratively, I went, collected data, kept going over and over again, and effectively collected it all out. And now skipping over all the fun technical details, what is the question, the so what that came out of this? DNSSEC, as I said earlier, provides cryptographic methods for authentication of your domain so that somebody can actually look up and say, the DNS records or the response that I'm getting is authentic. It's cryptographically proven both by the owner of the domain, but more importantly, it's signed by the next level of the domain up. So if you're getting, it's all about anchoring trust. And the countries are signed, etc. Most countries today have some support for DNSSEC. Not all DNS registrars have support for DNSSEC. And I found here that things varied quite widely. The last stats I did for CoZA as a representation of the .za domains, because that was what I had a nice cache of host names to look at, was still just over 1% of the domains in CoZA supported DNSSEC. Have a look at the Nordic countries, where it's almost a default for most of the registrars there. I think Norway's sitting at upwards of 70% of domains have DNSSEC enabled. And it's enabled at the registrars, which means that the clients don't actually even think about it. It's just there and it's done. Sweden's the same. Netherlands has got very high rates. Belgium's got reasonably high rates. Estonia, high rates. Spain, not so high. Russia, almost non-existent. So it varies very much around the country, and so much of this seems to depend on the registrars and whether it is a default opt-in. And in many of the Nordic registrars, it's automatically there. It's just turned on. So it doesn't have to be thought about. Whereas many of the other countries, one has to talk to a registrar, manually insert the records, manually manage the records, etc. CAA was it's a relatively new DNS record type. And it was introduced again to help bolster trust. We'd spoken about how DNS is integral to the idea of the X509 certificates, or as they're better known, the HTTPS certificates or SSL certificates. The DNS is important, and so the CAA record effectively allows a domain owner to explicitly state these certificate authorities are able or are given permission to issue for my domain. And it's again a mechanism that's been put in place in trust so that I can't go to a new certificate registry and decide I'm going to register a certificate for CHPC.conf.co.za, for example. Register that, and then I can use that as part of a phishing attack, etc. But hey, it's a legitimate certificate. By going and using these CAA records, the owner of the domains can explicitly say who they provide permission. And many of the large certificate authorities now buy into this. They will not issue a certificate unless they're explicitly trusted by the CAA records. And this, in many ways, it's a further abuse of the DNS system in some senses. The DNS system was never intended to be a trust anchor, but it's used for things like CAA. You have the text records we put in place. If you're wanting to authenticate your domain for Microsoft or Google to be able to make use of their services, you need to create a specific text record. So what I found from the CAA survey, that while I was querying all these domains, I just queried for the CAA records as well. Very, very low uptake, exceptionally low uptake. Across all the domains, probably less than 5%, which is interesting because the cost of gaining a SSL certificate or an X509 certificate really has dropped. It's dropped all the way to the best price ever, which is 0, using things like Certbot, etc. But Certbot, for example, respects these records, so it's interesting that we haven't seen a mass uptake around these. So that was some of the ancillary findings, is that we've got some of these security mechanisms, but they're not really being used in DNS. And unfortunately, that was very much a foreshadowing for Act 2, looking at the critical risks around DNS. And the questions really that I wanted to ask myself here is, so what? It's 2 a.m. Do you know who controls your DNS servers? Think about it. Do you know where your DNS servers actually live? What nation state is going to ruin your day, or potentially ruin your day? And one of the challenges we've got is that while the internet is fantastic, you can get from here to pretty much anywhere in the globe in 17 to 20 hops these days. You are still at the mercy of anybody whose network you're transiting, and you're potentially at the mercy of a foreign government. It says, we don't like you. We are instructing all our companies that do business with you to shut off services. What would happen with that? And we'll see some examples. The US features very prominently here, probably for largely historic reasons, for cost reasons due to economies of scale. The US features really, really heavily as a core source of DNS for the internet, certainly for the countries that have been surveyed. Now, what would happen if the US decided sanctions effectively? No provider may resolve DNS for this country-level domain. We would see some major disasters coming in. So where do we find value? I had all this data. I looked this morning. I think it's sitting at about 1.7 terabytes of compressed data now. It's huge. And it's, as I said, one of the lessons I've learned is I need to learn how to store data better and in a more efficient manner, and how do you expire old data. But yeah, lots of data. The analysis really has only just started scraping the surface of what's there. And I like to think back to many of you will be familiar with the works of Donald Knuth, where he said the premature optimization is the root of all evil. Don't over-optimize before you understand what you're doing. I think I'm at the point I understand now, and I can now start backfactoring and doing some optimization. The big takeaway is, of all the domains that I did the survey on, again, going back to the disclaimer of this isn't necessarily perfect data, they're all at risk of influence by foreign players on their critical infrastructure. And this comes back to saying that DNS really should be treated as national critical cyber infrastructure. Same way as your telcos, etc., because without it, so much stuff actually breaks. What has also come out is that there's a mass of opportunity to do further research around this. In many ways, DNS is the unloved stepchild of the internet. Goes back to the opening slides that I had there. It wasn't DNS, it can't be DNS, oh damn, it was DNS. People don't care about it when it works. When it stops working, well, it can be very, very interesting to diagnose. I've been caught short many times, lots of hours spent doing diagnosis of network faults. Turns out the DNS was working, it was just not serving the information I thought it was actually serving. So with this, there's lots of further opportunities for exploration, and that's sort of certainly one of the things I'm working with a number of my students in doing some further exploration, trying to build better tooling and insight coming out of this. There's also the need for threat modeling for the domain name infrastructure, not just the DNS names itself, but how do we build things, how do we connect things, where do we place them? And there is, if we go back to the early days of the internet, there's good documentation as part of the RFCs around DNS saying, well, if you've got a domain, you shouldn't have your two servers sitting next to each other. They should be on separate subnets, ideally separate routing paths, separate buildings, spread them as far apart as you can in terms of that. And that's become a whole lot easier. We can have local DNS, we can have a secondary DNS server sitting on something like the Amazon Route 53 services or one of the other providers out there. But I've not been able to find anything really focused around the threat modeling for DNS. And I think that's a really interesting opportunity, particularly if we're going to take this seriously and say that DNS should be critical and regarded as critical infrastructure. If it's critical, we need a threat model. We can have threat modeling for nuclear power plants, for big telecoms outages, for denial of service attacks. But I certainly haven't come across anything that clearly says, here's a good model for threat analysis of DNS that unloved protocol that is so core to what we use. So looking through some stats now. If you want the stats, I can happily provide them to people afterwards. But I want to just focus on a couple of key things here. So for South Africa, the proxy that I had was a fairly large list of COZA domains that in itself resolved down to roughly 18,000 unique name servers. And then when I looked at them, 62% of the name servers, US-based. You actually, when you factor in Canada, 63% of our domain name servers, and remember each name server can control multiple other domains, is sitting in North America. South Africa comes in at only 14% of all the name servers are actually located within South African IP address space, and that is probably worth talking about how the analysis is done. I use some of the commercial geolocation tools for all the issues around geolocation. They're still relatively accurate at a country level. So I use tools like MaxMind. I also pulled and built a lookup service using the official allocations from the various internet regional registries. Where's it allocated to, when was it allocated, etc. I know IP blocks there's a whole black market for IP address blocks, etc., but we've gone on best effort sort of lookup here. Other places we're seeing hosting in South Africa, Germany, France, Britain, Netherlands, all places that have cheap hosting facilities, have many providers that offer DNS, etc. So that's South Africa, not too bad. 63% in North America, 19% in Western Europe. So the vast majority of these DNS servers are not in South Africa. Go back to the cable incidents we had. That means potentially, what are we looking at? 82% of the name servers are sitting offshore. Potentially means 82% of the name servers are impacted. What I haven't actually done a full breakdown of yet is mapping that down to specific domains and trying to sort of put a weighted score around, is this sort of Fricky's tuck shop that is hosted overseas versus a large corporate domain, and how that works. Norway, on the other hand, only 6% of the name servers for the .no domain are located in Norway. Those name servers themselves do serve a fairly large proportion of it. Again, 56% in North America, 20% overall in Scandinavia, 30% in Western Europe. looking again at the current sort of geopolitical climate, we've got some things. 90 are hosted in China, 82 in Russia, and 2 in Iran. Make some interesting questions around these kind of things. Australia was another one. com.au, there was actually a fairly nice list that I was able to come across and be able to use. 26,000 domains. But again, the same kind of trends that we're seeing. 67% of the domains sitting in North America, 7% in Western Europe. They're not too bad in terms of 20% of the domain servers are actually located in Australia. That's better than most countries, actually. But still, North America and Western Europe, topologically, physically, are still quite some way from Australia. I just want to, at this point, say that diversity is good, but one needs to have managed diversity. And if you've got one server sitting locally, 2 servers sitting overseas, it's not a bad thing. Diversity is good. One needs to just have it managed. United Kingdom, again, I use co.uk as a proxy. Even there, where there's relatively cheap hosting, etc., 43% was based in North America, 23% in Western Europe. From a geopolitical perspective, that's currently a relatively low risk. But again, we saw 142 in China, 298 in Russia, 54 in Iran. And I'm singling those countries out because that's where many of the geopolitical tensions are sitting currently. Belgium, same kind of issues. Russian Federation, and this is really was a surprise to me. I'm really sorry I hadn't actually started this data collection before February 2022. As I said, the news that Russia had issued a national edict to say, bring your domains home. We're going to host them internally because we fear what's going to happen as part of the sanctions packages that were rolled out. 45% of the name servers for Russian domains are located in Russia. That is a remarkably high. An interesting anecdote, and again, this comes back to where things get blurry in the data, is 223 servers are notionally located in Ukrainian IP address space. Now, that has become increasingly blurry over the last 2 years, so I wouldn't attach too much to it. It may be one of those things we can just sort of sweep away under the concept of fog of war, but it is interesting. The key is that 49% are still sitting in Western Europe and the USA, and it's still not clear how the economic sanctions that have been pushed out against Russia, certainly by the US and Western Europe, have actually impacted this. So that's something that sort of remains to be seen. Looking at it overall, taking the Majestic Million list, this was 140,000 distinct name servers for 1 million domains. So these, on average, these name servers were serving fewer domains. Again, 40% in the US, 7% in Germany, 5% in France, and it goes down there. Effectively, with the exception really of Russia and Japan, the majority is actually sitting in Western Europe and the US. So with all that sort of preamble out the way, this is where if we get to it, I think I've got about 10 minutes left. Yes. What is the impact that came out of this? The so what, really? So impact 1, there are 20 IP addresses. If you could take those out, 75% of Norwegian CCTLDs would be unavailable. I'm not going to tell you what those 20 addresses are, but to take 20 IP addresses out is not a particularly difficult activity, certainly for nation-state level actors. These 20 IP addresses are all relatively easy to get to. They host other things. But this to me was sort of a warning call saying, you know, everyone talks about critical infrastructure, about telecoms, our water, our electricity. 75% of .no domains rendered unusable by just taking 20 IP addresses out. Taking an attack on the top 5 name server providers in the US will take out 10% of the co.uk domain and impacting roughly 440,000 domains. Again, very targeted attack. This could be a denial of service, it could be a hybrid attack, it could be a purely cyber attack. Somebody could go and cut fiber optic cables, physical attack if you really wanted to. None of this really is beyond the reach at nation-state level. Attack on the top 5 name servers for Belgium takes 20% of the domains out in the country. Some big DNS providers have resilience, but there's still a very large proportion of domains that go to much smaller providers that don't have this. Another one here that we really need to think about is, if we go back to the concept of Animal Farm, which I'm sure many of you are familiar with, all IP addresses are equal. What is clearly comes from this is that while all IP addresses may believe they're equal, there are definitely some that are far more equal, or we could replace that with critical, than others. And one of the challenges we have, and that we commonly make use of in the networking sort of fraternity, is it doesn't matter. You can move a server around on IP blocks. It doesn't really matter. But what enables that? It's functional DNS that allows us to move servers, to be able to dodge denial of service attacks, etc. So what really is the impact? We've got a relatively small number of systems that can be targeted, that can result in fairly large impacts. What is the risk, really, of foreign hosted systems? And I think it's important to say I don't have answers for these. This is really, in many ways, a case of saying, here's some problems. Anybody got really good ideas? Should we be looking at DNS as critical infrastructure? Are my stats completely wrong? And that's something I'm completely open to. Somebody's got better quality data they want to share, we can go through this, and maybe I am completely wrong. Maybe I am sort of being Chicken Little, shouting that the sky is about to fall. Maybe I'm not. So yeah, what is the impact really of foreign-hosted DNS servers, foreign-hosted domains? What does that really mean? I'm bringing it back to some very more recent events. And this is a high-level map of the various submarine cables around the world. And as many of you are aware, there's been a fairly high-profile incident in the Baltic in the last couple of weeks. Two cables having been impacted there. Is this an accident? Is it an act of geopolitical influence? Is this a physical manifestation of cyber conflict? Is it something else? We don't know yet. We will probably find out in due course. And there you go, it was right from the start. Germany came out and said, this is an act of cyber warfare, cutting our communications infrastructure. It could be an accident, but again, when you start looking at the balance, I won't draw your conclusions, but there's a lot of arguments in both directions. So really, what happens when the unexpected occurs? And for those of you that don't know, this was the Nord Stream, a picture of the Nord Stream 2 pipeline in the Baltic that blew up. A gas pipeline. Suddenly it blew up. Nobody knew anything about it. There's a wide variety of theories around who did it. Depending where they come from, they generally accuse somebody else. We don't actually know at this point definitively what happened. But this is exactly the same thing could be happening. We see there's an increasing amount of news looking at the threats to undersea cables, to terrestrial communication links. And so really, when somebody blows up our DNS infrastructure, what happens? So really, at the end of the day, the devil is in the details. I've got an idea of what's happening. I think I know what's happening. I think it's worth raising as a discussion point. In a forum like this, where we're looking at NREN, where we're looking at a lot of security stuff as well, is probably the right kind of place to talk about it. So really, to wrap up, DNS is an amazing technology. It is absolutely amazing that a technology conceived nearly 40 years ago is still working today, is scalable, and not only just scalable, but performing well. Despite all of this, it's remarkably misunderstood. Go and have a look at pretty much any university curriculum. DNS is a small footnote saying DNS is used for resolving from a name to an IP address and vice versa. Well, that's certainly what it used to be, but it's a whole lot more, and it's this general lack of understanding that I think underlies the vulnerability to the DNS system. People don't understand all the places where it's effectively got its tentacles into. And with this, nobody cares when it works. Absolutely no one cares when it works. When it breaks, suddenly it's a crisis. Why didn't we do better around this? It's the world's largest dynamic distributed data store. And we've got the data challenges going on with the students. And that's an interesting model to say is, how big is DNS? How many billion records do we actually have? And yet we can resolve most of them in under 50 to 100 milliseconds. The distributed nature of DNS makes it really difficult to create momentum for change. Are some domains or subdomains more important than others? And there's the whole dependency tree that I've quietly sidestepped as a problem in what I've been talking about. But country A uses country servers that have a domain name that is in country B. Country B gets impacted by country C. What is the net impact on A because of these dependency trees? So there is a problem. I think there's a problem. Other people might disagree with me. I'd love to hear if you disagree with me. I think the problem is potentially quite bad. I think we should worry. And here's the one solution I've got. Effectively, how do we go about making it better? Work with national CSIRTs, registrars, create awareness, start having a discussion around DNS as critical infrastructure. To really get good quality data, we need to work with national registrars, with national CSIRTs, longer term monitoring. How are these things changing over time? And at the end of the day, I've actually been left with far, far more questions than the initial, fairly naive as, hey, what is the dependencies around where DNS domains are actually located? And so that brings me to the end. I've got one more slide to answer the question that I suspect is coming. In my bio, it said I'm a reichenologist. Reichenology is the study and collecting of old wooden woodworking planes. Something completely different from sort of the electronic world. I quite enjoy collecting sort of pre-1850 type wooden planes. So that is it. Thank you very much. If you've Yes. Are there any questions, comments, rotten fruit? That's one of the big things that now that I've got this, going back to the how do I build better queries. And a lot of that is how do I better store the data so that I can ask those kinds of queries. At the moment, this has been a relatively raw take and saying, sort of just breaking it up at a country level, not looking at diversification. I'd like to come up with some kind of scoring mechanism for a domain to say, well, you're so far apart, and we can, certainly in Western Europe and the US, geolocation is good enough to actually get to a city level. So you can start working out, are you outside the blast radius of a 10 megaton bomb, for example, if you really want to go apocalyptic? Are you on different things? So that is definitely on the sort of path in the future. But you make a very good point there. I think it's one of the things, again, that you make exactly the case of what should be done. There should be better distribution. But it boils down to a lot of it as being economics. It's much easier for an ISP to maintain NS1 and NS2, and all their clients are registered on that. Should they really be NS4, 5, 6, 7, and 8 that are actually geographically located, or maybe you've got NS1 and 2, but 3 and 4 sit somewhere else. And I think it's a discussion that actually needs to be held in places like the Network Operators Group, looking at NREN type discussions, looking at and in South Africa it's probably something like ZANOG or IOZ, having that kind of discussion around what is best practice for our community. And then at the national registrar level, possibly looking at some kind of scoring or warning mechanism. Congratulations, your domain's registered, but do you know that both your DNS servers are on the same subnet? That's a red flag. I think that is almost the best place to do it, although with the sort of mass democratization of DNS, it's really easy for anyone to register a domain. Most of the end users are not going to understand that, and that boils back down to the DNS registrars working with the national sort of domain authority to try and have better mechanisms, provide the feedback to these registrars that, great, you're registering domains, but you're really not following best practice in terms of redundancy and resiliency. All right, if anyone wants to talk to me about the data and stuff afterwards, I'm around for the next 2 days.
Thank you very much. Thanks a lot to Perry. I think both Perry and Lisha, they gave us deep insights in terms of how do we deliver the internet and also the impact security can possibly have in delivering of internet services. I think you also mentioned the two blackouts we have in this calendar year that impacted most of the internet users. I think most of the researchers that were mostly in the research and education institutions, they were not that much impacted thanks to Sandren and also our Tenet, the partners that are operating our network, were able to survive that one. But we are still working as much as possible to see how are we resilient, especially on the submarine cable with number of geopolitics issues that are impacting the submarine cable resiliency. We're working on that. I think even Lisha talked about the Polar Connect project. Barry talks about the geopolitics that may also impact the DNS services or even the provision of the internet as we know it. But thanks a lot to both our keynote speakers this morning. I think after this we will break and then move to the breakaway sessions. Token of appreciation to Perry. Thank you.